All right, guys, so we're getting toward the end of the nitrogen cycle, and I need to bring you into this end of the nitrogen cycle. It's really anthropogenic, okay? So anthropogenic means, anthro meaning mankind, and genesis meaning like beginning or creation. So that literally means man-made. And also, this lesson is really an overlap with the carbon cycle. So I will try to make this make as much sense as possible. But what we're going to start with is looking at my actual truck. Okay, so obviously this truck is anthropogenic. It's man-made, and everything this truck does is man-made. So let's give you a rundown on how it works. So this is the engine here, and it's run on gasoline. So this is the gasoline motor, and I'm sure you watched my other videos, so you know that gasoline is a hydrocarbon. And I know what you're thinking. Well, Rainey, if this is a hydrocarbon, what does it have to do with the nitrogen cycle? Well, remember that all of this air here is 78% nitrogen into gas. And right here, hopefully I'm getting the camera right, this is the air cleaner, the air filter, okay? So atmospheric air, even though it looks sealed, it's not. It appears to just be a closed box. Air goes in there. Air goes in here, feeds into this engine, and then the hydrocarbon fuel, which is hydrocarbon, gasoline is carbon and hydrogen, that's why it's called a hydrocarbon, goes in there, and the engine burns the fuel air mixture using, you may not be able to see these coil packs here, but there's spark plugs under those coil packs. The electricity creates a spark that ignites the fuel air mixture under pressure. That's important. I'm not just explaining to you how an internal combustion engine works. So if you don't know how it works, then we need to learn that. But when that fuel air mixture burns under pressure like that, it explodes. Then the N2 gas, the nitrogen gas that's in here, what's going to be created is a nitrogen-oxygen compound called NOxes, NO sub X. Now we put the X there as a variable, just like in algebra, right? But really, so it could be NO, NO2, or NO and free radical oxygen that forms NO2 somewhere between the front of the engine and the back or whatever. But what's going to be created is nitrogen dioxide. We can call this NOxes or NO2, nitrogen dioxide. That is going to be created in the engine and expelled out the exhaust. And I'm going to take you under the truck and show you the exhaust in just a second. But when that is created, that's a primary pollutant. Primary pollutant, okay? And the reason it's a primary because that's what's directly created in the anthropogenic system, this truck being the anthropogenic system, and the NO2 is directly created there and expelled into the environment directly from this machine. Now, it doesn't stay NO2, nitrogen dioxide. It combines with water vapor in the air, H2O sub G, H2O being water, sub G meaning the gaseous form, water vapor, that is in the atmosphere, okay? So that NO2 combines with the H2O sub G and creates HNO3, nitric acid. That contributes to acid rain. That's part of the acid rain problem. Now, it's not the only part of acid rain. So H2CO3 is what happens when the CO2 that's created by this pickup truck combines with water in the atmosphere, creates H2CO3. That's carbonic acid. And then there's also sulfuric acid that's being created, and that has to do with coal burning power plants creating H2SO4, sulfuric acid, in a very similar set of equations. What's actually created is SO2 or SOxes, and those combine with H2O sub G, water vapor, in the atmosphere to create H2SO4, which is the final part of acid rain. It's actually 3 different acids that create acid rain. And I realize there's a huge overlap between the carbon cycle here with this pickup truck and the nitrogen cycle. But things are complicated. It's just the way it is. They're not 2 separate things. All of it is connected. All of it is happening all at the same time. So let me take you up under the truck. And hopefully I can show you some more parts and pieces under here. Okay, so this object here is the catalytic converter, and you see over there, this is a V8, so it's putting out a lot of gas, a lot of vapor, and those catalytic converters there are helping reduce some of the air pollution issues. Not all of the air pollution issues. Every car now has catalytic converters. Most pickup trucks, this one only has 2. Most pickups these days have 3 or sometimes 4. Now back there is the muffler. Hopefully you can see that. Over there, that's the muffler. The muffler is supposed to help with noise pollution, okay? Now in this truck it doesn't help with noise pollution that much. Okay, but that's what the muffler is supposed to do. It actually has nothing to do at all with reducing air pollution. It does reduce pollution, just not air pollution. The catalytic converters, on the other hand, that's their job, is to reduce air pollution. Now, catalytic converters can get clogged over time. This truck actually needs new catalytic converters. It's got over 275,000 miles on this pickup truck. So these catalytic converters need to be replaced. Right now, they're probably not filtering much at all. Okay? And furthermore, the mufflers doesn't really reduce noise pollution much at all. Matter of fact, probably makes it worse. But anyway, in cars now, then they have much better catalytic converters. In fact, California has their own specifications for catalytic converters. There's California spec catalytic converters now that are much better. And furthermore, they need to be replaced on cars in order to continue filtering the air properly. All right, so in continuation, as we talk about, motor vehicles and the pollution they cause. So we've already talked a little bit about their role in the nitrogen cycle. Now we're going to continue on with that a little bit. So out of this muffler here, I need to get here we go, much better. Okay. So out of this muffler right here, and I'm not going to touch it because it's hot, but out of that muffler, so this is gas coming from the catalytic converters up there, the way I've already showed you, that came from the motor up there. So the gas is being produced by the internal combustion engine, called an ICE, internal combustion engine. You've got fuel-air mixture being burned under pressure, and that's going to create nitrogen dioxide, carbon dioxide, and we talked about their role in creating acid rain. CO2 also has a huge role in being a greenhouse gas in the global climate change crisis, or what we call global warming, however you want to call that. Anthropogenic climate change, whatever terminology you want to use, the Earth's getting warmer, and this, and CO2 from vehicles has a lot to do with that. Now, other things are going to be created here too, that are actually going to come out of the tailpipes. Right here is atmospheric ozone is going to be an issue. VOCs, volatile organic compounds, which is going to be unburned gas in this case. There's lots of VOCs, paint, glues, all sort of stuff. But in this case, it's going to be unburned gasoline. The more efficient the motor is, the less unburned gasoline, the less VOCs there are. Now, VOCs, nitrates, the nitrates that are coming out of the vehicle as well, are all going to react with sunlight. See the bright sunlight out there behind me? They're all going to react with sunlight, and they're going to and pans are going to be created. And there's this interaction between nitrogen, pans, ozone, all in the presence of sunlight that's going to create photochemical smog, the pans, okay? Peroxyl nitrates. So that is all part of the nitrogen cycle, and it all starts with motor vehicles burning atmospheric air, 78% nitrogen, under pressure, and coming out with these nitrates eventually lead to the pans, which is the photochemical smog in the presence of sunlight. It's a complicated set of reactions, but it's not hard to look up. In fact, if you just Google image search pans, capital P-A-N, lowercase s, chemical reactions, and you go to images, then you'll see full diagrams of how that's created. Or you can type in photochemical smog, chemical reaction, and hit images, and you'll see all the chemical reactions that go into this. Now, let's talk about one other thing. Okay, so you saw some of the smoke coming out of there. You can't usually see car exhaust, but as So you see water coming out of there. Water is also created in all combustion reactions. That's why that's happening. But anyway, you can't really see it, but it's there, okay? Now sometimes you can see it, and what you're seeing, that sort of smoke or soot look that you see around the tailpipes there, that is particulate air pollution. Particulates are another set of air pollution. There's not a chemical reaction that goes with that, but there is lung irritation that goes with that. Now, more efficient motors have less particulates that go with that. You can't smell this through the camera, but you can smell car exhaust, and the VOCs is what you're usually smelling. Carbon monoxide that is also in that in this car exhaust, you cannot smell at all. Carbon monoxide has a separate set of issues, and it can be lethal. The NO2 or the NOxes, nitrogen dioxide, you can't see it or smell it. It's just there, okay? CO2 is the same way. You can't see it or smell it. So a lot of times you don't realize how much car exhaust is going on because you don't really see it. Okay? Hey, rev it up. Alright, here's the other thing. Noise pollution. Cities are particularly loud, and vehicles are part of it. It's called road noise or vehicle noise. Vehicle noise raises the volume of cities, and that's why there's a whole set of pollution issues around sound, a constant exposure to sound. So motor vehicles really interact with the carbon cycle, with noise pollution, with the nitrogen cycle, with many things that, like sets of chemical reactions and pollution issues that all come back to motor vehicles, okay? So when you think about vehicles, don't put it over there as part of the nitrogen cycle or part of the carbon cycle. It's part of lots of things.